Yes. So good morning, everyone. It's a pleasure for us to be here today. We are, as you can see, a team of 3 people. The 2 main developers and testers, and I'm a hobby backyard astronomer, interested in technology, of course. So today we wanted to share a project that combines these 2 worlds, using some IT for a practical use case in astronomy and astrophotography. And so, by the way, we advertised the presentation in English. Is there anyone who's not happy with it? Should we do it in German, or should we mix it a little bit? Or is it English is okay for everyone? English is fine? Okay. So we're here as well at the booth. If you have any questions, we are also presenting the project out there in the project zone at the entrance. And you can approach us in English, in German, and in Portuguese as well. So almost whatever you like. Okay. So let's do a quick intro. So Lucca, I don't know if you want to say something about yourself real quick.
No, I'm just a student from Brazil. I was first in contact with Raspberry Pi here, and I started for 5 months to program. So I'm only starting, so don't expect something very complicated.
I'm Lucas, I'm 12 years old, and I'm testing the whole thing, if it works, and because I don't understand something about this, it's very good that it's easy to use.
Yeah, and I'm Boris. I would call myself a product owner. We've done this in an agile style. For those of you familiar with agile software development, it's very communicative, very iterative. So I would call myself a product owner, which is basically the guy giving the requirements. And then you walk away, kind of. I mean, you communicate a lot, of course, with the team. And the team in this case are these 2 guys here. And it turned out to be the perfect combination, really. So today, we don't only want to show you the technology. The technology is pretty basic, but it's an interesting use case. But we also want to share some experience on how you can actually realize projects also with your kids, teaching them about technology and building stuff. And this is a very relevant project for us. It's a very practical use case with some real value, which is important. So I started giving them the requirements, and they started delivering stuff back to me, like what you would call a requirement or a user story. And then we did a review round. And then the ideal combination is really Lucca as the developer, doing the technology part, and then Lucas, who is starting to get into technology, but has just the right level of understanding to check it from a more, I don't mean this negative, but a more naive standpoint, just checking the functionality and validating if it's working or not, right? Without understanding all the technology, which is actually ideal for a tester, right? So you don't want to get into all the stuff. You want to treat it more like as a black box, right? So that was really a cool combination. Okay, it takes a minute. So let's quickly introduce the observatory that we're talking about here, so you get an idea of what it is. This is a backyard observatory. It doesn't look like one. When you have an observatory setup or layout in your mind, you think about the dome, right? I mean, like this large thing with a huge scope in it, and then you open up a little window in it. That's not how backyard astronomers build their observatories. I keep this short because that's not the main focus, but it's interesting to give you some context. Usually in a dome you get several problems. You have to operate it with an expensive motor. You have very little room. It's exorbitantly priced. So what you want to do is you want to use a normal wooden garden house and you want to adapt it. So what we did is we basically cut away the roof. So you cannot see it very well here, but the roof is kind of like separate. So we separated the roof from the base at the very top, and we put some like wheels under it. So you can just, as a convertible, you can just roll it off. And then you got the sky above you and it's magnificent. And you're standing in your garden house and it doesn't have a roof anymore. So of course there's some wooden extensions like bars going out from the observatory that you can roll the roof away. And this is a very manual process. And astronomers are as lazy as IT people. So what we want to do is we want to automate that, right? So we had to find something to automate this. First thought is, let's use some garage motor device control unit. but that's boring. I mean, you can buy it off the shelf and then you install it somehow. You want to do it yourself, right? And the other factor, of course, in that is all that astronomy stuff is actually very expensive. So when you get into it and start buying stuff off the shelf, which is pre-configured and pre-built, you spend a fortune without getting a lot of value out of it. And just for operating the roof, come on, you don't want to spend a lot of money, right? So what we said is it has to be cheap and reasonably priced. And so we came up with that Raspberry-based solution. And we said, okay, let's build a prototype. So it's not working yet. That's what Lucca also just said, right? We haven't installed it into the house yet. But we have a working prototype, and we build it as if it were the house. And of course, there's a few steps still that we have to do, but at least the software and stuff is operational, and that's what we wanted to share with you. And we've got plenty of ideas for follow-up projects. There's so much in astronomy that you can automate and fiddle around with. So you can do your auto-guiding to track the stars, and do go-to to find certain objects in the sky. You can automate the camera control and all kinds of stuff. And this is a playground like these model trains. You will never stop to keep building it, you know. So there's a lot of ideas for future stuff. But we thought, let's start simple and improve from there. So I got another picture real quick. That is a long exposure when we actually build it. So you see this is like a 6 hours exposure or so. So we have that mount, the house is not around it yet. And we had to configure and install a lot of stuff there. Okay, so let's talk about from my side, from product owner side, what do I want here? I already explained a number of these things. We want to have a cheap solution, and it should be like the understanding what that technology can do for us, right? So is it easy to use? Can school students and kids do it? Is it simple and is it quick? And is it also able to not just do the normal operations, but is it also fault tolerant? That's very important when you control the roof, because you don't, one thing is for sure, you don't want your roof to fall off from to the back or to the front, right? So it has to be kind of fault tolerant as well. So, and it has to be, which is also interesting, we haven't done that in the prototype yet, but it has to be resistant to weather conditions, because you're basically operating at minus 10 degrees Celsius, up to 20 maybe or something, different dew points, you know, all kinds of different weather influence, so that's interesting. And in the long run, this is also something that opens up the possibility to run something which is called a remote observatory concept, so you could actually fully automate, right? And that is very interesting as well. In the long run, you could think of putting your observatory somewhere in the world, probably Brazil or wherever, and then in a nice place, and you can remote control it. And if you connected it to cloud sensors and weather detectors and stuff like that, then you could eventually even really like operate autonomously. Future, but it's a start, right? So I would at this point like to hand it over to Lucca, who is going to explain. So these were the requirements for me as the dumb astronomer guy, right? And so I talked to Lucca as the designer and developer of the project. And so we came up with a certain design that, Lucca, I can also turn this around here. So you can maybe just quickly walk us through the design.
The design of the program is very simple. We have some expectations. So, for example, if the roof is open and the user press stop, the roof will stop. Or if the roof is open and you press close, it will close the roof. So it's this combination of the expectation and the user action that will trigger some action. So our components are basically the Raspberry Pi. We have 2 sensors yet, and now that one is to see if the roof is closed, the other to see if the roof is open. 3 buttons to control: open, close, and stop.
You want to switch to the camera already, or maybe?
Can we?
Because we also got the software design, but we can switch to the camera at this point if you want to show it. Okay. So again, if you want to see the prototype live and test it out yourself, it's very basic, but still, it's interesting. You can come by our stand out there, and see it yourself. So this is the view from above.
Okay, thank you. 3 buttons. We have here the relays. The relays have a separate energy from the Raspberry Pi. Raspberry Pi cannot handle high voltage, so to keep it safe, the relays are powered separately. Then the Raspberry Pi. The 2 sensors here, they are infrared sensors, very simple, and the LED that shows the state of the roof.
So you want to switch back again? Okay, so yeah, so as you can see, it's a simple design just involving 2 infrared sensors at each end, 3 buttons, open, close, stop. That's basically it, right? And then of course the relay to control the motor and separate the motor from. But we use low voltage right now for the prototype. Obviously, when we start operating the roof, we have to upgrade that to real power, right? Because we have some stronger torque that we have to apply to the roof, right? Yeah, so this is the implementation. This is the schematic. If you want to explain it shortly.
Yeah, only say that we had in the event handler, there is basically 5 triggers. There are the 3 buttons and the 2 sensors. And the way that they react, they related to each other, is the base of the program. It's not so complicated, right?
Yeah, you wanna. Yeah, so the idea of the event handler was really like to have a very lightweight and easy way of separating everything logically and abstract the functions. So not just have everything hard coded or so, but one of the development patterns that Lucca developed while doing it is actually to encapsulate the logic into the functions, how you should do it, right? And this is something that we learned while doing it, right? So that is a very important thing in software design, that you want to keep things abstract and logically separate. And it turned out keeping this event handler, which you can see in the pseudocode on the right-hand side, separate from the actual logic, which is then embedded in the functions, is the discipline you want to apply, right? Okay? So let's go further 2 now. One more. Okay. Then, of course, nothing just works, right? So we went through some problems. And so this is like the testing process now that Lukas and Lucca wanted to explain to us real quick.
Yeah, and when Lucca programmed a new thing, he showed me and I tested it, and we have a list of problems that we found and solutions. So we had the problem that it was difficult to set the color of the dimming from the LED.
So we only didn't do that. So the idea was to make, when it's opening, a tone of yellow, and when it's closing, another tone of yellow. But that's actually difficult to make. You have to set I don't even know how to do that. So we just made blue and dark blue. That was only combining blue and red, and only blue in the RGB LED. Really simple.
Then we had the problem that the buttons had several functions. That's the complex UI.
Yeah, my first program, I tried to build a kind of menu. So, like 3 buttons that you can control a lot of functions only with 3 buttons. But that wasn't really a good idea. It was very complicated, was difficult to use, and it took me a lot of time to make, and now I just made everything simple.
And if I may just interrupt, that is actually an excellent example why agile software development is so great and produces good results. Because without that quick feedback loop, you would not detect that. People would go off, I mean developers would go off and do their thing, right? And then you come up with a complex menu nobody understands. We started working only with 2 buttons, so Luca thought, oh, I have to do everything with 2 buttons and so on. And then we said, we have to simplify, right? But that feedback was very direct. I mean, of course, we're anyway in the same house, but in a team, it's very important to have that direct feedback loop within a couple days and stuff. So that was an excellent example, and that really brought down the code a lot as well, from a very complex, almost non-understandable, monolithic thing to a very structured, easy design. So again, agile, iterative software development, communication helped a lot here.
Yeah, then I found the problem that the relay didn't switch the power.
Yeah, it was all because of the cables. I spent a lot of time trying to understand why the relays weren't working. I thought that maybe the relays were broken or something, but the cables, the jumper wires weren't working. It was so dumb.
Yeah, the message is don't start going through the code all the time. I mean, that is also something that sometimes it's just a freaky little cable, you know. So that is something we learned the hard way. The kids learned the hard way, right? Yeah.
And sometimes the button events triggered, but although no button was pushed. And
that's also something I learned, that the GPIO inputs, there are some floating voltage, and to solve that, there are some built-in functions. There are a built-in resistor in the Raspberry Pi, so it can handle these floatings. And you can also use some resistors in your buttons.
yeah, and then we had the problem that the LEDs locked, the sleep time locked the system from the LEDs.
When you use a time.sleep function in Python, it locks the program, so you cannot, the program just stops. So if I use time sleep while the motor is running, I wouldn't be able to turn the motor off because of the time sleep. So we had to find another way to make the LED blink without using this time sleep function. And we used we got the time of the system, and we waited till this time is the same as the time plus 3 seconds, and then we turned the LED off, so the event handler would always keep testing it.
Yeah, so basically, I think the last one is an interesting pattern in software design. When you start thinking straight and thinking more serialized, you would basically just run that sleep time function, but then the system locks and cannot do anything else, right? I mean, people who are programming among you know that. So how do you kind of like keep the system responding while it's on that sleep mode, so that, for example, the LED is lit up for 3 seconds, or that something else should happen for a limited time, but the system should still remain responsive. And there's a lot of patterns for that we found out on the internet, of course, like, you know, Googling for whatever you can find there. So we found an easy-to-use pattern by just storing the time in another variable and using the time as another trigger event. So when the time is reached, then do that. Else, you know, just keep processing and circling through the event or looping through the event handler. So that's one thing you can do. There's, of course, other patterns as well. But that is a very simple way of dealing it, and then keeping the system responsive. That's what it was all about, right? Okay, I think we're through this, right? So, okay, so the next step obviously is to take this whole prototype, and I, as the product owner in the review, formally accept it. I think the kids have done a really great job. And also the presentation was not easy for them. So thank you very much, guys. That was really good. I think you deserved some quick applause here. Thank you. Thank you very much. And so me as the product owner, I'm really excited and to see how they've done this, how they figured it out. So there's going to be some next steps for us, of course, like, okay, we need to bring this into real life, and that's another challenge, obviously. So we have to do this together in the next couple of days and weeks. And we've got a lot of ideas about what else we could do. We could publish the code. We could have programmable positions and things like that. I'm bringing this up because all of that we already almost started implementing already, you know. And then we said, no, we have to simplify this and keep it straight to the core, you know. Start simple, just with the inner functionality, and then start building story by story and evolve slowly and really bring it down to what's really the absolute minimum of the problem. And then suddenly you will be successful. That is the learning from us from that project. And then there's tons of other things that we can envision. I mean, you can read it out for yourself. There's a lot of like this remote automation thing that I mentioned already and stuff for future projects. I haven't seen a lot of Raspberries being used in observatory control. I know there's a couple of easy, simple projects here and there, but bringing it all together would really be like a dream platform where you have like a control dashboard and a lot of different elements that come together in one foundation. So don't think we will be able to build that, but hopefully the community, and maybe we can contribute a little bit to that as well in the long run. I want to take one step back real quick and just, you know, using this project as an example of what you can achieve with your kids when you want to do projects like this, and what we've done and what the lessons learned are from that perspective, right? So stepping away from the technology, what I found is you as the IT geek try to get into it too much, right? But that's wrong. I mean, not necessarily wrong, but what you should try to limit yourself to is give some guidance, explain the problem, make sure the kids understand it, and let them go off and do their thing. Give them the responsibility and the trust that they can actually solve the problem themselves. Because when you start writing the code yourself and putting the cables into the grid and stuff like that, then it's, you know, I mean, it's you doing the project, not them. And then what's the learning effect from it, really? Let them make the errors. This is why we presented the errors or the traps to you that we found. Let them make these things. Let them learn from it. There's no due date in this project, at least usually not. And give them something relevant where you can see a tangible value. That's another learning. So for us, the observatory is something that we have out there, and so we have a real project rather than reading something from the book and thinking, what could you do with it? And maybe I destroy it afterwards again. So here's something really persistent, you know, that makes a difference. And I think it's very important in this process to really, I mean, guide them when they are in trouble, to say so. Help them a little bit, but inspiring them how to solve the problem and not just solve the problem by yourself. I think that's a very important thing that I found difficult for myself, actually, because, you know, when you want to get into things, you also want to understand what the problem is and how to solve it. But you have to take that extra step back. I think that is probably the most important learning here. And, I mean, it worked very well for you as well, right? Because you could really get into the technology and learn it without getting the big thing, you know. So, yeah, that was cool. So I think we are at the end of that core part. How much time do we have left? We wanted 20 minutes. Okay, perfect. So we want to accept some questions, and I have a few pictures for you as well that I just want to run through real quick. So it's like a side story from what can you do with an observatory to motivate you a little bit doing some backyard stuff as well. But before we go to that, just to make sure we have all your questions answered, do you have any questions regarding this? You may also ask your questions in German or Portuguese if you like. Yes, please.
So I was wondering what the time frame of the project up to now was. How long did it take you? How much time did you spend each week? What was the total time that you spent on the project?
Yeah, Lucca came to Germany in February, end of January actually. We started with the project maybe a few weeks into February, something like that, end of February, beginning of March. So the overall development time up to now was roughly 3-4 months. I have spent some time initially explaining the requirements and then like reviewing it every 2-3 weeks really only, and then only spending like an hour from my side, not much, you know. Again, trying to not get into it too much. How much time would you say have you spent?
No, not really, because I have also learned Python in this time. So maybe 4 months.
But you spend like, let's say, 1 or 2 nights every week almost, I would say, roughly, right? Learning, I mean, but that includes the whole learning process of Python, of Raspberry, how to set up the Raspberry, how to do the wiring and the cabling, what kind of motor, you need a relay, okay, how do I do that? You know, so the whole learning process was actually 3 to 4 months with a reasonable investment every week. Yeah. Any further questions? Yes, please.
How did he learn Python? Did he have a text or just by trial and error?
Yeah, I mean, of course, on the internet, but we also got some books.
Yeah, some books.
Which books did you use? Can you recommend something?
I don't know all the names, but it's one of these.
I know there's a kids programming book for Python, which is pretty cool.
Yeah, there is this.
And that's the reference, the Bible, how we call it, the big one.
There is a site that I think that's very good. It's called Academy. It works very good.
Yeah.
And the basics from that.
Yeah. So, I mean, that learning process really is like you would get into the things. You start with a book, ideally an intro book like Python for Kids, and then you start evolving from there. And then, of course, when you do your project, you start Googling around. You'll always find it. You just have to find the right search words, right? That's more the challenge than anything else. Okay. Any further questions? Yes, please.
How exactly do you detect the end of the movement?
There are these infrared sensors. So there is one in the end and one in the start. Yeah, there is infrared light and a receiver. So
yeah, it's just a IR
so
detector.
Here is the infrared LED, and here's the receiver. So simple as it.
This is the prototype. In the real world, you would definitely want to have like a physical switch in addition to that, because you don't want that to run off without it being detected or something. So that's a cool way, I think, also for the final version. But you want to have backup, that's for sure. Right. And the backup here in that design that we just showed you, the backup is very easy to add. It's not, it's not chaotic, but it's just another event then. So if your backup fires, then you want to stop the roof as well, right? Okay, any further questions? Then let me give you just, this is not directly related to Pi, but I hope you will all appreciate the quick sideshow here. I wanted to show you this picture. This is taken from our garden. These are noctilucent clouds, NLCs. For those of you not familiar with this sighting, it's actually becoming more and more not popular, but frequent in our latitude. Usually it's more to the north, but now during summer you see this a lot. These are ice crystals. These are not real clouds, but these are ice crystals 80 kilometers high up in the atmosphere. And if you're lucky, you see them during summer in the north. And I saw like 3-4 days ago, there were some first sightings from Poland. If you want to see these, keep watching just after sundown or just before sunrise, so that the sun is a little bit like 10 degrees or so below the horizon. So the sun kind of like illuminates these ice crystals high up in the atmosphere from behind. And then you get these really like white and gray thin lines. It looks very interesting. And you can take pictures with your normal DSLR camera. With a smartphone might be difficult, but you probably still can get a good shot. So this is something which you can easily do from your backyard when you just search for it, when you're aware of what you have to look for. And again, during summer. So this is probably something you want to look out for. You can look at the moon, you can look at the sun. I just keep going through this real quick. I know we are standing between you and your lunch, so. But if you want to talk astro or astrophotography, you can come by as well. So this is the sun that we did some pictures. And when the sun is active, which you can see on top with filaments and prominences, then on below it you have all these nice aurora displays. Not here at our latitude, but more up north, of course. This is the Milky Way. This is basically the whole sky in one picture. So we're going out a little bit from our solar system now, looking at our Milky Way. A lot of stars. And then zooming into the Milky Way, so you can do this kind of stuff. This is still standard DSLR. You don't need a fancy thing here. You can take lenses, tripod, exposure times up to 20, 30 seconds. And then the trick is to get rid of the noise sometimes, take several pictures and stack them. There's a couple of programs out there. So with the standard DSLR, you can get pretty nice results already. You just have to control the noise a little bit, you know. And noise control usually works by taking several shots, and then when you do like an average processing of them, then you can get rid of the noise. There's some programs. You don't have to do that all manually. Okay. And then, so these are some of these we have actually taken from Namibia, so that's not really from our area here, but some of these are actually really from our Backyard Observatory. So, so you can take some deep sky shots of some objects here as well. For that, it's a little bit more difficult with the DSLR, so you need that mount and that scope that you've seen in the beginning and in order to take these shots. But what you can do is, if you know a guy who has that, you can just bring your DSLR and put it on top of the scope or the mount, and then you can use a guided, you can do guided shots. And officially, if anybody is interested and you want to come by, the Backyard Observatory is less than 20 kilometers from here. Just give us a ring or just, you know, call us, drop us an email, and you can come by once if you like. Okay, and then this is all stuff that is still in our galaxy. When we go even further out, right, then you get to other galaxies, like the Andromeda galaxy. And this, probably you've all seen pictures like this before. This is also from our Backyard Observatory, when the roof is open, of course. And this is actually something you would not believe, but the Andromeda galaxy on the sky is almost as big as the moon from the sky area it occupies. So why do you not see it like that? Because it's so faint, right? So you can make this visible by taking astrophotography pictures. And this is really like why we like this, you know, persist the memory and share the excitement and share this, because otherwise when you just see it through the scope, it's not possible to share. So photography is an important thing to actually show what you can do with it. Okay, so I think we're at the end of the session then. Thank you very much, and enjoy your lunch. And again, if you want to come by, we're here for the rest of the day at the entrance in the project area. Thank you.